Alright, we're on, I want you to be on this, it's got this table at the top. We're not going to use the table, but go to that page, and then we're going to skip past the table. Our calculator does, you can do this stuff, we're going to do two ways. One is using this giant table, which is a pain in the butt. Two is using the calculator, which is what we're going to do. You got it, Davis? Alright, so, yesterday we did, and don't write this part down, but yesterday we did, those don't, most of those don't have batteries, and I don't want you to sit through them right now while I'm teaching to try to find out which ones do. So that one works great, otherwise sit down. Oh, I know where yours is. First day I gave it to you, you left it here. Yeah. Alright, so if the mean is like 100, and the standard deviation, we did IQs yesterday, right? So the standard deviation is 20. Don't write this down. So we had like this, and then we had the percents, and I could say like what percent of the data is above 120, for example. And you would add up those three parts, and you get a number. But that only works if you're on like those numbers. And it's actually an approximation. It's like a really good approximation. That's 68, 95, 99.7. It's very, very close. But it's still an approximation. So the question is like, what if I wanted to know like what percent of the data is above like 129.6? And what you would need to find is like the percent that's over here. But you can't just add up the pieces because you don't know like the percent by those pieces. So we need a different way. So let me go back to that. Alright, so I'm going to draw this out. You don't have to draw it every time, but I want to show you what we're finding. So what proportion of the values lies under z equals negative 2.5? So I'm going to put my mu in the middle. That means mean. If z is negative 1.25, is that going to be to the right or to the left of the mean? Left, how do I know? It's negative. So like somewhere over here is z equals negative 1.25. And I want to know what percent of values. So it could say what proportion of values. It could say what percent of values. It could say what's the probability. And it could say what's the area. I put those four things on the board over there. They're all the same question. I'll write them on here too in a minute. They're all the same question. So what proportion, what percent, probability, all the same thing. And I want to find what is over here. Okay? So two things we're going to put on the number line. Way over here is actually negative infinity. Like if I went way to this side, it'd be like negative 10, negative 30. But if I went like forever, it'd be negative infinity, right? The only problem is I can't really type infinity in the calculator. So instead of putting negative infinity, I'm going to put like negative 9999. And that just like represents negative infinity. And then on the other side, like this goes forever and ever. It goes all the way to infinity. But again, I can't really type infinity into the calculator. So I'm going to use 999. And you can put a ton of 9. So you can put more and more. Basically, as big a number as you can put in. And what I want to do is find, you're always going to be looking for the area between two things. So if I'm looking for the area, I know it's underneath negative 1.25, but I'm going to think about that as between negative 999 and negative 1.25. So like my lower bound, my left-hand side is negative 999, and my right-hand side is negative 1.25. So what you're going to type into the calculator, I'll show you in a second, just write it down for now. Normal CDF, that's like normal, like the normal word, and then CDF means cumulative distribution function. You will never have to say or hear that again if you don't want to. It's not like a thing that matters. I'm just telling you. People are like, what's CDF? And then I'm going to put negative 999, comma negative 1.25. And yeah, I'm going to stop. So that is saying normal CDF, lower or left-hand bound, comma, upper. That's what we're doing. And this is used to find area, percents, proportion, probability. Those are all the same idea. And we could kind of guess based on like our percents that we did yesterday, but there's no need for that. So let me show you how to do this in the calculator. Are people still writing? Whatever. Oh, my bad, yeah. Please yell at me, but I probably do that a lot. So, like, tell me if I can't see it. Are we good? All right, let's go to your calculator. And you want this, like you see up here above bars where it says DISTR. Right here, where that is. So DISTR, that stands for distributions. We want to hit that. So I never know if I'm supposed to, if I say to press that, should I say second bars or should I say second DISTR? Like, should I say this button or the thing that's up there?
Second button. Just say DISTR.
Or just say DISTR?
Yeah.
Alright, you want to hit DISTR. So it's second and then the bars button. However you want to think about that, I don't know. And then you're going to scroll down to normal CDF. What? You got 105. 0.105. That makes way more sense. Okay. Then type in, and I know there's two different kinds. Type in negative 999, comma, negative 1.25. Close the parentheses and hit 0, or hit enter. And you should get 0.105. But I would like someone that has, because there's one that pops up with like a menu, right? Can I grab one of those? It presents differently on the two calculators. It's the same calculator, but it's like two different operating systems or something. So yeah, this is how this should go. If you have this one, you put the lower bound here, the negative 9999, upper bound here, and then these just default to 0 and 1. So you just leave them. And then if you hit paste, like that's exactly what we just typed in, except it's got the 0 and 1. But don't worry about that right now. And you'll get the same thing. Is that okay for that type? Do you have a all the way back? Thank you, Angie. Okay. Let's go to this one. So I don't know if let's call that number 2. You can answer that without your calculator. You can answer it right now. It's 0.105. This is a symmetric distribution, right? So everything's the same on both sides. So if Z is negative 1.25 here, and the size of that is 0.105, well, if I put Z equals 1.25 here, what's the size of that have to be? It has to be 0.105. So you could like verify it. Especially on a test, I know some of you guys like to do the problem like 2 ways, like make sure they're the same. So I could definitely do it and verify it, but I can also shortcut it. So if that's my mu, here's Z equals 1.25. This is 999. So I would type in normal CDF 1.25, comma 99999. And if you want to do it, like to verify, go ahead and do it, but you will get the same thing because it's symmetric. So, yeah, stay on both sides. Questions on either of those two or how to use it at this point? They're just probably doing the next one third. Alright, so if I do this, let's call this number 3. And again, you don't have to draw it every time. There'll be sometimes I ask you to, but drawing it every time is just annoying. I'm only doing it because I'm teaching it. So I've got Z equals negative 1.64 over here. It's to the left of the mean because it's a negative Z score. Z equals 2.33. It's going to be to the right of the mean. Should it be further from the mean or closer to the mean than this one? It should be further, because 2.33 is bigger than 1.64, right? And I mean, it's not that big a deal, because it's just a sketch, but we're looking for what proportion of values, what percent of values, what's the area, what's the probability. Those are all the same thing. And so I would go normal CDF, negative 1.64, comma 2.33. For that one, I get 0.9396 or 0.94. Round to where it makes sense, whatever that means. Again, if you're not sure if you're putting enough decimals, just put more. There's nothing wrong with putting more. Is that okay for 3? And then 4, I'm a little sick of drawing. Hopefully it's okay if I stop. But that would be my left hand or my lower boundary. And that would be my right hand or my upper boundary. Did you get 0.907? Oh, crap. I didn't read it right. You guys will do this on the test, and I'll get annoyed that you didn't read the question. I didn't read the question. This, thank you. So Z equals 1.34 is here. I can fix it easily. Z equals negative 2.78 is here, but it's asking above or below. It's asking that. So from my answer, how could I get to what I'm supposed to have? Subtract it from 1. Because the whole thing has to add up to 100. Or you could do them like separately, but that's my bad. I should have had 1 minus that. Thank you, whoever said that. Someone over here. Thank you. My bad on that. Does that make sense what I did and what I should have done, what I did wrong? And hopefully I didn't screw anyone up there. I did it wrong because I just assumed that it asked for between these two, but it's asking for like what's above this and below this. So I followed this kind of by accident, and if I just subtract that out, I'm left with. Does that make sense? Blaming Luke for your problems over here. I know, I'm just joking. Because he left it here for a week. Alright, turn the page. We're going to skip number 1 for now. That's kind of like an advanced question at this point. We'll come back to that type, but not right now. So number 2. So right now, we're not putting data in our formula. We're putting z-scores in our formula. So we have to standardize everything. We're going to standardize this data here, get a z-score, and then do like the normal CDF thing. So my first job is to find the z-score for $10. So remember, our data point is x, so z is x bar minus mu over standard deviation. Our data point is x bar. The mean is the 27.21. And then the standard deviation is 7.9. So this is 10 minus 27.21 over 7.93. So I get negative 2.17. We good on the z-score, do we agree? So if I were to kind of sketch that, again, you don't have to, but I think it's very useful to at least like think about it, even if you're not going to sketch it. And then it says, what percentile does that place in? So we don't know what percentile means. Percentile means the percent of people that are below you, right? If you're in the 99th percentile, you're better than 99% of people. So I want to know the percent that is, if I'm looking for percentile, I want to know the percent that is below this. So over here. So I would go normal CDF. Negative 9999. Negative 2.17. not a lot of people are spending less than you spend. Cheap ass. Question on 2 there? Try 3. It's worded a little different, so make sure you are finding the thing they're asking for. This one's not asking percentile, it's asking top percent. Those are opposites. Like if you're in the 95th percentile, then you're in the top 5%. Does that make sense? If you're in the... Because it says I'm in 40 minus 27.21, I typed 0 minus 27.21. That'll do it, yeah. 1.61? My bad. Dang it. Okay. So, but we got to get this percentile top percent. If you're in the 90th percentile, you're above 90% of people, and you are in the top 10%. Fair enough? So the top what percent of spending, I'm looking for this side. If it has percentile, I'd be looking for this side. So I want this and above it. So 1.61, comma 99999. So I got like 0.054. So you're in like the top 5%. Number 4, they do not give you enough information. We're gonna fix that in a second, but can you tell me why, anybody? What other information would I need? No. Yeah, why do I need to know that?
Because this is just the population finding every single person in America, but you don't know what the population size is.
So what are we finding? We're finding a percentage. So if I find out, like, let's say this is 10%, then, well, 10% of what? So I would need to know, that just tells me percent. Are there 100 people at this Fiesta market? Are there 10,000 people? So percentage and amount are two different things. So let's just fix it, and let's say there's 500 customers. Now try number 4. the z-scores I got. Do we agree? Remember, what does the z-score tell you? Standard deviation from the mean, and the positive or negative tells you whether it's below or above. And again, you don't have to make the graph, but I think the visual helps you learn it. So we're looking for this part in here, that area, the percent, the probability, however you want to phrase it. So I got 0.455 for my normal CDF part. Agree there? Is that my answer? It's not. What is that? That's a percent. So normal CDF finds percent, probability, area, that stuff. So we found a percent. So now I know 45.5% of the people spent between $20 and $30. And I know there were 500 people. So I multiplied them together. But if you didn't know the amount of people, you can't really do that one. So that was a mistake on the worksheet. So it's 227.5 people. Which doesn't really make sense. But okay. For that, what it is it's people. If it was like, I don't know, something you could take a decimal, you would think that. Question on 1 through 4 then. Alright, number 1, on the next part. There's the z-score formula has 4 variables in it. Z, x bar, mu, and sigma. And I should be able to, that's just algebra. I should be able to give you any 3 of those things, and you can find the 4th one. Just by doing cross multiplying or some algebra. So these are just practicing that. So number 1, I know my formula is that, and they're asking what's x. So I know the z-score, I know mu, I know sigma. So the z is negative 2.3. X is what I don't know. The mean is 23. And the standard deviation is 5. And then our job is just to solve that to find x bar. So I would probably multiply both sides by 5. Over here, that just cancels. This will give me negative 11.5. Equals x bar minus 23. And then I would add 23 to both sides. And I will get 11.5. Okay? Do number 2. So sort of a quick way you can check, like this won't prove that you're right, but sometimes if you're wrong, you'll realize it. My z-score was positive, yes? Which means my data point should be above or below the mean. If the z-score is positive, that's the number of standard deviations, right? So if it's positive, we're above. So is this number bigger than our mean? It is. That doesn't prove that we're right, but like if it wasn't, it would kind of prove that you were wrong. You should do something else, So unlike this last one, we had a negative z-score. So our data point should be below our mean, and it is. It doesn't verify that we're correct, but it helps, like, convince me a little, you know. Questions? I don't think those are too bad. And then there's one more thing, and this is a lot. Like, this is throwing a lot at you in one worksheet, and we'll spend a couple days on it. Because now we're going to go backwards. So, let's write it like this. If I have data, and then over here I have percent, proportion, probability, theory. To go this way is what we just did. So I gave you data and I asked you for the percent, or the proportion, the probability, or whatever. We can also go backwards. So going backwards is called inverse norm. So that would be where I give you the percent or the proportion or the probability and ask you to find the data. So it just flips the other way. And the inverse is like a nice name for that, right? It's easy to remember. It's the opposite. So if I look at number 3, again, I'm going to do the graph because I think it helps you learn and visualize. You don't have to. Got my mean. 20% of the data lying below a certain spot, and I'm looking for that spot. Is that spot going to be to the left of the mean or to the right of the mean? It's going to be to the left, because there's only 20% below. If I went to the right, it would have to be like at least 50% below. So somewhere over here is z equals, I don't know, but I know this area is 0.2, or that percentage is 20%, whichever way you want to think of it. And so you want to go backwards. So you're going to do inverse norm of 0.2, and it'll tell you the z-score. So inverse norm is in the same menu as the normal CDF. So dister, second bar, second dister, whatever. Inverse norm is right below normal CDF. And on this calculator, it's 0.2, but on the menu card, does it ask you for like mean and some derivation?
Area.
What area? Just pick one.
It says area and then left, right? Yeah. So okay, this would be. So that's what you do. Area is 0.2, and then this is like the default. And for now, we're just using the default, so these just stay 0 and 1. And I did paste. So the only difference is you have that 0 and 1 there, which is just, again, it's just the default. You don't have to worry about it right now, and that's the same value I got. Thank you. Well, I showed them both. Is that okay for 3? There's blank pages. Try 4 and 5. 4 is a little trickier. 5 is a lot trickier. Well, give it a shot. See how we do. Correct. It's only 34% above. You're higher. stack.
Whatever.
Try 4 and 5. If you're stuck, just wait. That's fine. Like, I'm not expecting you to know how to do these. I just want you to look at it at least before I start explaining it. Got it. So you get to decide. Like if it says by the area above, choose right. Below, choose left. So that's like a good finish. You don't have to do as much work. Yeah, that's not right. That's zeros. If it's below, choose left. Above, choose right.
Percent.
But then the middle one,
So that's the right. By subtracting one against doing it.
you have to do left, so they cut it in half. Yeah, so that works. It's a lot easier to avoid doing that. It's like 5, that's it.
It's not much extra.
You have to add 2. It's gotta be a positive.
Yeah, that's like 1.5. Yeah, I have to
Yeah.
Yeah, it's just a-
Like what I did was I did 1.
So we go to the next one. Yeah, you have this center, so you can cheat and you realize how. So you can choose left or below, right or above. Yeah, just like
That's why you have to add 2.
you have this guy too. So you guys will right. I'll show you. So center left and right, so highest percent below. Middle.
It's
So you don't have to do it the same way. We have to kind of work around the fact that our calculators don't do that. Does that make sense what I'm saying? Yeah, those are your two things. So you guys got a lot easier than okay. So 34.5% of our data lying above a z-score. So I liked right away. People were thinking like, should my z-score be positive or negative? Like I heard 2 or 3 people go, this should be positive, right? And that's good. Like really think about kind of where your answer should be because it helps you know if you are on the right track. But if only 34% of the data is above it, it's got to be on this side of the mean, right? Because if I went past the mean, it'd be like more than 50%. So I know this is 0.345. But my calculator, this kind of calculator, unless I just talked to you about your fancy cheating calculator, our calculators only think in terms of below. So I have to go inverse norm 1 minus 0.345. So if this is 0.345, over here is 0.655. And unless you have the fancy calculator, you have to use this number because your calculator, when you do inverse norm, automatically assumes you're telling it the percent below. If I ask above, you've got to flip it. When I mean like subtract 1 from it when I say flip it. So I've got to do inverse norm of the 0.655. And I get 0.399-ish. So those of you that have the cheating calculator, you can just hit like right. Put the z-score and put right. You can say number. Cheaters. All right. No, you can. What's even more annoying is because I've had, I don't know, they got new calculators for the intro stats class, and they're all like the sweet cheating kinds. And we have like the old crappy, yeah.
I saw that.
Yeah. All right, 5. 5's a little tougher. And that 4 is a little tougher too, I think. But 5, and again, if you have the cheating calculator, huge benefit for you. But I'm asking for the middle 35%. So that means that this here is 0.35. And I've got to find, like, what is this z-score and what is this z-score. They're going to be the same number, right? It's symmetric. So whatever this one is, this one will just be the negative of that number because it's symmetric. It's the same on both sides. But your calculator only understands percent below. Like, I can't tell at 0.35 because it'll give me where 35% is lower. So I need to find, like, this decimal here. So if 35% is already gone, how much percent is left? 1 minus 0.35 gives me 65% remaining. But that needs to be split among these two sections, right? So 0.65 divided by 2, so 0.325. So that tells me this area here is 0.325, and that's the area I need to tell the calculator, because the calculator only does lower or less. So I'm going to do inverse norm 0.325. And so I get negative 0.45. And, like, make sure you understand what that is. That is this z-score. It's negative, so it's 1 left. But they're asking, like, what are your z-scores? So what is this z-score? 0.45. If you really wanted to double check that or do some extra, what percent of the scores are below this spot? 0.675? You'd add them up, right? So if you do inverse norm of 0.675, I get 0.45. So it's like another way to get to it. You can either find the one on the left, and then just like, oh, it's symmetric, so I'm going to make it positive. Or you can find the one on the left and then the right, and just do it like 2 different ways. I would like to do another one of those. I would like you to do another one of those. So find the, let's say I'm just making up another number. Middle percent, middle, I'll rephrase it. Um, 55% of data is in the middle, symmetrically. Find the z-scores. I'll give you a second to walk around and answer questions, and then I'll come back. Those are all dead. Oh, you can watch.
That one is all work.
So at the end, one. Do you want me to throw them away now, or do you want to hold on to them so later in class? All of these ones are good. Sort for. There's a blank page, like a page behind. That's where I went. Sorry, I love them.
I remember you talking about that, and I figured it was.
So I went through like all of my classes and tried to identify it, and I saw that, and my heart just dropped. But then there were like 2 or 3 other letters that you didn't say. But like, so were you like kind of worried that they were probably not? Yeah, I mean, yeah. just go 0.55 center, and it gives you both, and you're living a charmed life. If you don't have that, we've already used 55% of the data, so there's 45% of the data remaining to be split evenly among these two parts. So 0.45 divided by 2 is 0.225. And to find that z-score, I can do inverse norm of 0.225. So I'm telling the calculator what percent is lower. Should this be a positive or negative number? Negative because I'm below the mean, right? So I get negative 0.755. Before I go to the next part, are there questions on how I did that part? So for the other one, you can do it two ways. That's probably good to understand both. But if this is negative 0.755 and it's a symmetric graph, what does that have to be? It's got to be positive 0.755. But just to show you another way, you could do the same thing and tell the calculator what percent of the data is below this z-score. So to do that, you would just add up these two. So that's like 0.775. And again, some people like to do it on the test like twice and make sure you get the same thing. That also gives me 0.755. So now I've done it two different ways. I got the same answer. I feel like rock solid that I got it. Questions on that? Alright, so I want you to try, I know we're still in the notes, but I'm going to give you it for like an assignment. 6, 7, 8, 9. So finish up the notes. There's like 4 problems. I want you to try those. Depends how much I can read. I don't know. Like I started grading them yesterday, it's super fast except for that graph. There's like a million different ways you can do it, so that really like bothers me. What I'm hoping that. How do you know you did?
I feel like most of my drawing exactly words. Because one of the answers where you're supposed to just leave it as like 2 sine
2 sine 3.
I just leave it as 2 sine 3.
What'd you do?
I'm just getting this to go all the way out and spin it as a full triangle, and then I realized I'm practically wrong. So I guess that was wrong.
I'll just see what you did. Like I don't understand how you act on it.
No, I was like, I just can't do it. Just that kind of
Depending on what it looks like, you probably get at least.
I think 2 sine 3 might be scratched out. I'm sure you can see underneath.
I'll look for it. Because that sucks. You get the right answer and then you like spoil it. Try to do more. Would you mind doing it?
Yeah.
Like you know, right now.
Yeah.
There's 2 though. I don't know. Find out. You might get stuck on these. I don't know if they're easy or hard for you yet. So don't freak out if you don't get it. We'll go over tomorrow.
I don't think there's
So, you don't know this. We don't know this. How do you go to the board?
Over the weekend.
That's actually if you get stuck, please ask. That's why I give you time to do it. That's not
this only
Sure.
60%. Invert, right? Whatever.
My answer makes sense.
That's a huge thing to try, so it doesn't matter if it doesn't mean you're right. He's not sure wrong. I would absolutely write this little drawing, whatever, on your cheat sheet for the test. I would put it in your notes. This is like basically this section is this. Can you understand this? It's just going back and forth between percents and data. I don't know if my wheel makes sense. Hopefully you can follow that. That's like the key.
So then we
Actually, I should put z-score